Betty and Barney Hill, an American couple who claimed to have been abducted by extraterrestrials in rural New Hampshire on September 19 and 20, 1961. Their story was famous and became the subject of research and speculation. The legacy of this ordeal was a description of the extraterrestrials and a map of their space exploration and trade routes. It is the map we analyze here. The men stood about 5 feet to 5 feet 4 inches tall and wore matching uniforms with caps similar to those worn by military cadets. They appeared nearly human, but with bald heads, large wraparound eyes, small ears, and almost absent noses. Their skin was a grayish color. Together with the map and the identifying of their home star in 1968 by Marjorie Fish as Zeta Reticuli, the myth of the Reticulan Grace was born. But is it wholly myth? Or is it like many myths, and based on some truth? If this is pure myth, and as some have said, purely random, then we should expect to see just that in the map. 71% of the stars in the map are G-class, like Sol. Zeta 1 and 2 Reticuli, the root or base stars of our collection. These stars represent the home of a system of several stars spanning some 66 light years. Zeta 2 Reticuli has no confirmed planets known to date, July 2013, but does have a circumstellar debris disk. Both stars are thought to be old disk stars, but recent research has shown that they may be as young as 1.5 billion years. Hence, our estimate of 4.75 billion years, the average of the extremes. While there are no planets confirmed, the probability of planets and advanced sentient life remains extremely strong. The fact that the Hill Fish star map actually does match existing stars with such precision lends a high probability to the rest of the report. Given that, Zeta 2 in the map appears to be the front star, in that all routes connect first to Zeta 2. Routes to Zeta 1 connect only to Zeta 2. Zeta 2 is a virtual twin for Sol, but perhaps with a bit more. So, its habitable zone will be much like where Earth is in regard to Sol. Zeta 1 is a bit smaller, dimmer than Sol, and thus its habitable zone is closer in. However, the two stars are separated by enough distance, 3,700 plus astronomical units, that they each may support a planetary system. Zeta 2, however, is the only one with a debris disk, and thus may be more likely to harbor Earth-like planets due to more available water. 82 Eridani, a yellow main sequence star in the constellation Eridanus, a rather dim Sol-like star in the Eridanus constellation. 82 Eridani is one of the first stops on the routes traced in our map. While there are 3 rocky super-Earths confirmed, none of these planets are within the habitable zone of 82 Eridani. However, given that there are 3 planets, all more than twice the mass of Earth, it seems plausible that they may be masking the presence of a smaller, somewhat more distant planet. Tau Ceti, a yellow main sequence star in the constellation Cetus. Tau Ceti has 5 planets, 2 of which are in the habitable zone, even if just. Planets B, C, and D are rocky inner planets, with D being at 0.35 AU. Planet E, or Tau Ceti 4, is just at the inner edge of the habitable zone, at around 0.55 AU. It receives about 1.7 times the solar radiation that Earth does, so it is a very warm planet, surface temp around 70 degrees C. With an average temp like that, There are certainly areas where the temperature is quite Earth-like. Planet F, or Tau Ceti 5, is also a very good candidate for life. At the outer edge of the habitable zone, the planet is 1.35 AU from the star, and thus is rather cold. The average surface temperature is minus 40 degrees C. So there is very likely areas much warmer, and a slightly denser atmosphere would warm the planet to conditions not unlike Earth. Gliese 67, a yellow main sequence star in the constellation Cetus. It is shown in the original fish interpretation of the Betty Hill star map. This was a misinterpretation of the star. It should have been Upsilon Andromeda. As can be seen, Gliese 67 is a considerable distance from the location it was originally reported at. The star has been replaced with Upsilon Andromeda. Upsilon Andromeda was misidentified as Gliese 67. Judging from the position of Gliese 67, one could wonder if it was misidentified as Sol. Alpha Mensae, Gliese 86, Gliese 59a, Kappa Fornacis, all yellow main sequence stars, and in the constellation Cetus. This wraps up our G-class stars. 14.5% of the stars in the map are K-class stars. They are a bit colder and dimmer than Sol. 107 Piscium, an orange dwarf in the constellation Pisces, and 54 Piscium, an orange main sequence star in the constellation Pisces. 14.5% of the stars in the map are F-class stars. They are a bit warmer and brighter than Sol. Tau 1 Eridani, a white main sequence star in the constellation Eridanus, and Upsilon Andromeda, a white main sequence star in the constellation Andromeda. It is a stellar classification F9. Upsilon Andromeda has 4 known planets. One is near the outer edge of the habitable zone. This planet is very massive, probably a gas giant, at 3.75 Jupiters. But within the habitable zone, the probability of moons that may have Earth-like conditions remains promising. Again, if this is just myth and is random, then we should expect to see a random mix of stars, some suitable for life, others not so much. Including Sol and both Zeta Reticuli, there are 14 stars in this area of space. Of these stars, 10 are G-class, 2 are K-class, 2 are F-class. In nature, the distribution of stars is M-class 76.45%, K-class 12.1%, G-class 7.6%, F-class 3%. G-class stars are like Sol. Sol is a G2. Our map is 71% G-class. K-class stars do not burn as bright nor as hot as G-class stars, but they can be very long-lived. Many scientists believe these stars represent one of the best chances for Earth-like planets, and therefore life as it is known to Earth. It would be especially true for brighter K-class stars. F-class stars are brighter and hotter than G-class stars. There are 71% G-class stars, 14.5% K-class stars, and 14.5% F-class stars. Of these stars, all are capable of life as it is known on Earth. 3, aside from Earth, have known planets, with 3 planets between them inside the habitable zone of their star. It has been suggested that the map is only a collection of points. that are purely random. While this remains a probability, I would suggest that it is a far greater probability that the map represents exactly what it purports to represent: a map of Zeta Reticulan trade exploration space. The vast majority of stars are M-class stars. These far outnumber all the rest of combined, yet we see no M-class stars at all in our map. Instead, we have a mix of K, G, and F-class stars, heavy on the G. This makes the number of G-class stars rather puzzling. If this is to be considered random, then 10 G-class stars is disproportionately high, and the absence of M-class stars is equally inappropriate. Thus, the map is not random, and represents a view on the Zeta Reticulan trade exploration space. The original Hill map represents an artistic stylization of actual view on interstellar space. In our map, we show a view of these same stars from a known location in space. Further, that the description of the extraterrestrials, Betty Hill's description as opposed to modern stylized thought, is a relatively accurate description of a typical Zeta Reticulan.